Hello guys, welcome to Geek Check. Today we are going to talk about the subject digital electronics. Today we are going to talk about the very basics about the subject. Now let's discuss about two different types of signals, which are the analog signals and the digital signals. The analog signals are basically in the form of continuous waves like this. They look like this in this form. They are continuous in nature, while the digital signals look like this. We can take two values, either a high value or low value. We could represent the high value using a 1 and the lows using the zeros. This is how the digital signals are represented. Now, moving on, the analog signals are continuous in nature. They can take any value. Digital signals could take in only two values, high value and a low value. These high and low values could be considered as high and low voltages. Uh, they could be represented using just zeros and ones. Zero represents a high voltage and one represents the high value. We can use these zeros and ones, which are nothing but these voltages, in the logic gates to perform certain calculations. Look at these pictures. This represents the AND gate. A and B are the inputs and X is the output. The same is the case for OR gate, and these two represent the truth tables for the AND gate and the OR gate. For an AND gate, when we give two zeros, the output we get is a single zero, while we give two ones, the output we get is a single output we get is one. That is a high. While whenever we give a zero and a one, or a one and a zero, in either of the cases we get the output as zeros. While in the OR gates, whenever we give a single one could give the output of 1, while we give two zeros, the output will be always 1, 0, sorry. Now moving on to the other gates, which are the NOR. In the NOR gate, it just gives the complement of whatever input we give. When we give a 0, the output we get is 1, and when we give a 1, we get an output of 0. When the case of the NOR gate, it's just the complement of, could be considered as just the complement of the OR gate. Whenever we gave a 1 and a 0, we got a 1 in the OR gate. But when we give a 1 and a 0, or a 0 and a 1, or a 1 and a 1, we'll get 0 only. That is nothing but the complement of OR gate. This is how we represent NOT and NOR using the truth tables. Now, these are the NAND and the XOR and XNOR gates. Okay, now a NAND gate is nothing but just complementing the outputs of the AND gate. Whenever we ANDed two inputs, the output we got was not in this order, right opposite order. Whenever we gave 1 and 1 to the AND gate, the output we got was 1. But now, look at this case. When we give a 1 and a 1, we get a 0, and all the other three cases, we get the output of 1. Look at the case of XOR gate. In the XOR gate, whenever we give different inputs, that is a 0 and a 1 or a 1 and a 0, the output we get is 1. While when we give the same inputs 0 0 and 1 1, the output we get is 0 in both the cases. In 0 0 and in 1 1, we get the output as zeros. In the case of XNOR, you can see this in this table. Whenever we give different bits as inputs, see like 0 and 1 or 1 and 0, the output we get is a 0. Whenever we give